Welcome to The Explainer. Today, we're tackling a paradox that has stumped scientists for nearly a century. We're talking about a cosmic cold case that seemed to fly in the face of physics, the impossible, mind-boggling heat of the sun's atmosphere.
All right, let's jump right into the heart of the mystery, because it's a question that feels completely backward. How in the world can the air around a star be millions of degrees hotter than the star's actual surface? It doesn't make any logical sense.
And just look at how wild this difference is. The sun's surface, the part we can actually see, is sitting at a scorching 5,500 degrees Celsius. Hot, for sure. But its outer atmosphere, the corona, it's raging at an unbelievable 1 million degrees. That's like standing next to a bonfire and realizing the air 100 yards away is hotter than the actual flames. It's just bizarre. To put a solid number on it, we're talking about the corona being around 200 times hotter than the fiery surface right below it. This isn't some tiny little measurement error. It is a massive thermodynamic puzzle that scientists have been trying to piece together for decades. Now, for 80 long years, researchers had a prime suspect in this case. There was this one theory, proposed way back in 1942, that seemed to hold all the answers. But there was one huge problem. They could never find the smoking gun. The direct proof was just missing.
And believe me, this has been a long, long investigation. It all kicked off back in 1942, when a Nobel Prize winner named Hannes Alfvén predicted that these very specific magnetic waves could exist in plasma. A few years later, in 49, he's the one who suggested, hey, maybe these are the waves that are superheating the corona. It was a brilliant idea, but as you can see, that final piece of evidence, well, it took a very, very long time to show up. So what are these things? These Alfvén waves? Well, you can think of them as invisible energy ripples. They're magnetic disturbances that travel through the sun's plasma, which is just its superheated gas, and they carry these huge amounts of power along the star's magnetic field lines. Now here's where it gets really interesting. It turns out there are two kinds of these waves. You have what are called kink waves. We could see these. They make big magnetic structures sway back and forth. But they just didn't carry enough energy to explain the crazy temperatures. The real key, scientists suspected, was the other kind, the torsional waves. These are a really subtle twisting motion, and they were the missing piece of the puzzle. And that was the whole problem, right there. For 80 years, that crucial twisting motion was completely invisible to us. It was just too small, too faint for any telescope we had to actually pick it up. So the theory was stuck, just sitting there in limbo. But that all changed. It changed with the arrival of a groundbreaking new detective on the scene, a tool powerful enough to finally spot that missing clue. Meet the Daniel K. Inouye Solar Telescope. This thing is an absolute game changer. It's got a massive 4-meter-wide mirror, making it the most powerful solar telescope on Earth. It is capable of seeing the sun in a level of detail that is just absolutely unprecedented. But this telescope wasn't just about taking sharper photos. Its real superpower was its incredible ability to measure the tiniest movements happening in the plasma of the sun's atmosphere.
So how'd they finally see the twist? Well, using some really cutting-edge tech, they looked for something called red and blue shifts. See, as the plasma twists, one side moves towards us, which shifts its light towards the blue part of the spectrum. The other side moves away, shifting its light to the red. You've actually experienced this. It's the same Doppler effect that makes an ambulance siren sound higher as it comes at you and lower as it goes away. This was the fingerprint, the undeniable proof of those torsional waves. And that was it, the breakthrough. As one of the lead researchers, Professor Richard Morton, put it, after 80 years of just working with theories and computer models, they finally had the direct, real-world evidence to prove what they'd suspected all along. The case was finally cracked. So, why is this such a big deal? Well, this discovery is about way more than just solving an old puzzle. It has massive implications. Understanding this insane heat also helps explain the origin of the solar wind, that constant stream of particles flowing out from the sun that affects everything in our solar system, including our satellites and power grids right here on Earth. It validates a core theory of physics, and really, it just opens up a whole new chapter in understanding our home star. And of course, when you solve one of the sun's greatest mysteries, it just makes you wonder, with this powerful new eye watching its every move, what other incredible secrets has our star been hiding from us? Right there, in plain sight.